everyone, this is Miss Drake, and today we are going to be using polynomials to solve application problems. Most of them are going to be area and perimeter problems. So if you're in my class, we're on page 44 in your Unit 5 packet. It says lesson 55 at the top, but it's actually lesson 56. So if you have this packet, you could follow along. Okay. You can check your do now on the answer key, and we will get into the lesson here. So first thing we'll do when we have a word problem is we're going to read the problem. A walkway surrounds a rectangular garden. They have a picture for us here, but usually if you see a word problem about a rectangle and they don't have a picture, you'll draw your own diagram. This one's drawn for us, so we can just continue to read. The width of the garden is 5 meters, and the length is 7 meters. Okay, so that's the width of the garden and the length of the garden. So that's this inner rectangle right here. The width x of the walkway around the garden is the same on every side. Okay, so that's this distance right here surrounding the rectangular garden in the middle. Okay, so this is a 4-part question. First thing it's asking us to do is to write an expression for the total length of the garden with the walkway. Okay, that's from here to here, the total length. Then we'll write an expression to find the total width of the garden with the walkway. So that's going to be this distance here. After we do that, it's asking us to write an expression or a polynomial in standard form that represents the total perimeter of the garden and walkway. And then we're going to write an expression in standard form that represents the total area of the garden and walkway. So this actually came from a Regents question where they asked C and D but did not ask you A and B. So A and B are really the setup for how you would come up with the perimeter and the area on your own. So again, the first thing we want to do is write an expression for the total length. They don't give us the total length, but they do give us the length and the width of the inner rectangle. So let's go ahead and label everything we know. We know the width of the garden, so that's this inner rectangle, is 5 meters. So let's label that. That's on both sides, right? This is 5 and this is 5. We know the length is 7. So this is 7 and this is 7. Okay. So if I want the distance from, let's see, I'm doing the length first. So if I want the distance from here to here, I don't know the whole distance, but I can come up with an expression to represent the distance by breaking it up into pieces. So I know that from here to here is the same length as the garden. So from this dotted line to this dotted line is 7 meters. Okay. But then I have these 2 pieces of walkway on the outside. Well, I know that the walkway is x meters. So I'm going to bring that x up here and bring that x up here. So when I'm representing the total length of the garden with the walkway, I'm really adding together these 3 lengths. So I'm really adding together x plus 7 plus x. I'm going to combine those 2 x's together. X plus x is 2x plus the 7 meters that represents the length of the garden. So I have 2x plus 7 for this full distance. So x plus 7 plus x, I could write that up here, or 2x plus 7. I put the 2x first before the 7 because that would be standard form. We learned about that earlier in the unit. Okay, now we're going to write an expression for the total width of the garden with the walkway. So that's going to be from here to here. So this total distance. Okay. I'm going to break it up into pieces again. I know that the width of the garden is 5 meters. So I'm going to bring that 5 over here. I know from here to here is 5. And then I have these 2 pieces on the side. Well, I know that the walkway is x all the way around, so I'm going to label this x, and I'll label this x. So if I want the total width, I have to add these 3 pieces together. So if I'm doing x plus 5 plus x, I have 2 x's, 1, 2, or 1x plus 1x is 2x plus the 5. So here I'll write 2x plus 5. Okay. So once I have my length and my width, I can then go find my perimeter and my area. So if I want to write an expression in standard form that represents the total perimeter of the garden with the walkway, think perimeter means to add all of the sides. It's the distance around the entire garden. There is a formula for it, P equals 2L plus 2W, but you don't have to memorize the formula in order to do it. You just want to add all the sides together. So I'm adding the length twice and the width twice. So I'm going to start at one corner, let's say maybe here, and I'm going to first add the length, which I now know is 2x plus 7. So 2x plus 7. Okay. Now I'm going to add the next side. So I'm starting in this corner, I'm adding this piece, and then this piece, which is 2x plus 5, so plus 2x plus 5. Some people might put parentheses around their different sides just to kind of keep them separate. And now I'm going to add this length, which is also 2x plus 7, right? It's a rectangle, so whatever this length is also the same, 2x plus 7, so plus 2x plus 7. Okay. Plus this distance, well, if this is 2x plus 5, we know this is also 2x plus 5. So I'll add 2x plus 5. Because it's all addition, I don't really need the parentheses, so I could just drop those, or I can combine like terms from here. So because I want it in standard form, I want my x term to come first, so let's add all the terms that have x's. So I have 2x plus 2x plus 2x plus 2x. So 2 plus 2 plus 2 plus 2 is 8. So I have 8x plus, now I'll add all of my constants. I have a positive 7 plus 5 plus 7 plus 5. So add those four constants together, those four numbers together. 7 plus 5 plus 7 plus 5. And you should get 24. Okay. And then I just want to check what I get when I add and make sure it's in standard form. Okay. I have my variable term coming first and then my constant, so this is standard form. And this is a polynomial. It's simplified, all my like terms are together, so this would be considered the answer for my perimeter. Okay. Now I want to write an expression that represents the total area of the garden with the walkway. So that's the space on the inside. There is a formula for area. Hopefully you remember it from, I guess you did it in 6th grade. You probably did it in 7th grade as well. But the area of a rectangle is length times width. Okay, so I have to take the length of the rectangle and multiply it by the width of the rectangle. So really I'm taking these two expressions and multiplying them together. So I'm doing 2x plus 7, that's my length, times 2x plus 5. So for the perimeter, the parentheses were not important because it was addition. For the area, we do need the parentheses because we are multiplying a binomial times a binomial. Okay, so now we need to think back to our multiplication lesson. When we're multiplying a binomial times a binomial, we would use the box method. So since it's 2 terms by 2 terms, I'm going to set up a box, a 2 by 2 box. And I'm going to put this binomial here, 2x plus 7. And I'll put this binomial here, 2x plus 5. And then inside the box, I'm going to multiply the term on the left with the term at the top. So in this box, I'm doing 2x times 2x, which is 4x to the 2nd power. Remember, you're multiplying the coefficients, and you're adding the exponents. So 2 times 2 is 4, and 1 times 1 plus 1 is 2. For this box, I'm doing 2x times 5. So 2 times 5 is 10, and then just bring over the x. So 10x, plus 5 because it's a positive. Okay, in this box, I'm doing 7 times 2x. 7 times 2 is 14, and just bring down the x, and that's a positive. Okay, and in this last box, I have 7 times 5, which is 35, and that's a positive, so I'll put a plus sign. Okay, now I want to add together any like terms to write this as a polynomial in standard form. Okay, so I'm going to start with the term with the greatest exponent. Okay, so that's this term right here, so I have 4x squared. Then I want to look for the next greatest exponent, so after the 2 comes the 1, so I have 10x to the first power and 14x to the first power. Since I have 2 terms with that same variable and exponent, I can combine these two like terms. So 10x plus 14x is 24x. And then lastly, I have my constant, that plus 35. So I will put that on the end right here. And once I find my product, I just want to check to make sure it's in standard form, meaning the highest exponent comes first, and then the next highest exponent, and in descending order until you get to your constants. Okay, I also want to make sure there's no like terms to combine, but it's simplified, so this is my final answer. Okay, you're going to try the practice problems on the next page, and you can check your answer key in the instructions before you do the homework questions. Have a great day.